In this video, we're going to find the area of composite figures. Our learning target is that we will be able to use formulas to find area of composite figures. So in 7th grade, it's really focused on understanding and knowing those formulas. A few reminders and tips for remote learning. Remember, we are at the point in the year in 7th grade where we can use a calculator. If you are looking at the slideshows, not the videos, please make sure that you are putting those slideshows in present mode because it'll give you animations for the step-by-step on how to do it. And of course, you are here watching a YouTube video. There is a video that goes along with each slideshow, so please look for those in Google Classroom. Our first example, we're going to be using like grid paper to find the area. So you are basically finding like how many little unit squares make up our figure. So you're going to be looking at the number of full squares as well as the number of partial squares and basing it on that information. So when we look at the number of full squares, there are 45. And if we look at the number of half squares, there are 5 half squares. So putting that together, we have 45 full squares and 5 that are only half filled. So 5 times half, or half of 5, is going to be 2.5. Putting that together, our area is approximately 47.5 square units. Okay, this is just a way to kind of get a pretty good estimate of what the area is without exact measurements. Later on in the lesson, we are going to use exact formulas to find our area. All right, so I think you can go ahead and practice a couple of these on your own. You're counting the squares, the full squares, the partial squares. Please be writing this out on in your math notebook, and then come back and check your solution in the video. So go ahead and pause the video now, and I will see you soon with your answers. On your own, number 1, so full squares, there are about 33. Now you might have said maybe there was like 34 or 35 full squares. And then kind of looking at those partial squares and putting some of those partial squares together, maybe those partial square pieces kind of make up about 4 squares. So the approximate area here for this figure is somewhere around 37 square units. If you got 36 or 38, then you're right in the ballpark. All right, for this shape, we're going to look at those full squares. And then we have a bunch of half squares because we're pretty confident that those are half squares. I'm going to put those half squares together. So those 3 half squares with those 3 half squares make 3 full squares. And then on the other side, you have 2 half squares with 2 half squares, which makes 2 full squares. So that's also another strategy. We have 46 squares that are actually full that I shaded in red here for you. And then putting together those partial squares, I come up with about 5 full squares using all the pieces, the halves together. So our approximate area is 51 square units. All right, now we're going to head into the part of our lesson where we're going to be using formulas to find area of composite figures. So we are going to see rectangles and squares, parallelograms. So parallelogram has a similar formula to rectangles and squares, and I just clumped squares with rectangles. We also have trapezoids, triangles, and circles. So these should all be formulas you are familiar with from previous grade levels, and now we're using that to help us find area of composite figures. So you might want to come back to this or head to the slideshow and make sure you have this slide as a reference. Okay, so here is our shape, and I kind of already shaded it. This is from previously we did this where we counted the squares. So now I'm looking at it like, how could I break this into different polygons? So I color coded it. I have that light blue one as like as a trapezoid. We have a rectangle in yellow, and we have another trapezoid in pink. So kind of putting those pieces together, okay, our formula for a trapezoid is 1/2 times the height times the sum of the two bases. The bases are the two things that are parallel to one another. The height is the distance between them. You should be really familiar with rectangles there. So I wrote out all the parts for the area of each piece. Now we're going to go step by step, and we're going to solve and get, for the first trapezoid in blue, that's 10. Then 3 times 7 is 21. And for the pink trapezoid, we're adding 4 plus 7 to get 11. And then 11 times 3 to get 33, and then half of 33 is 16.5. Add those three things together, and we get 47.5 square units. Okay. Try not to get too overwhelmed by this. I color-coded it so you can just chunk out one piece at a time. Kind of think about your order of operations for the blue trapezoid, and then do your order of operations for the rectangle, and your order of operations for the pink trapezoid. You can use a calculator to help you with the actual multiplication. Okay, then we had another figure, and I want to bring up this idea as well, where we could think about this as finding a larger area and subtracting out pieces. So what if we found the large rectangle and then subtracted out that small little rectangle, a small triangle, and a pink triangle? So we get 56. And then that small rectangle is only 1/2, so 2 units. The triangle is also an area of 2 units. And then the other larger pink triangle is a 3/3, so 1/2 times 3 times 3, or half of 9, is 4.5. Okay, add up those things in parentheses first before you subtract. And so we're removing the area of 8.5 from that larger square. So it's a rectangle. So the area of the yellow piece, our composite figure, is 47.5 square units. And if you compared this to what we did previously with the adding the squares and the partial squares, you're going to get a pretty close answer. All right, this is another one that we did. And so if we divide this into our composite figures, some polygons that we know how to find the area of, we have a square, a rectangle, and a triangle. Our square is a 2x2, our rectangle is a 3x6, and our triangle has a base and height of 6 and 5. Okay, we're going to find the area of each piece and add those together, and it's 37 square units. And then we had this fun shape. So it's kind of however your eyes see the composite figure, breaking it apart. There's different ways that you can do this. So I kind of looked at it as 3 column pieces. We have the blue trapezoid that has the two bases are 2 units and 8 units with a height of 3. The rectangle is a 3x8. Now, the pink trapezoids, that's kind of interesting. So the pink trapezoids are the same. There's 2 of them that are exactly the same size. So that's why you see the 2 and then the braces and then the formula for the area of a trapezoid. 1/2 times 2, so that's the height. And then 2 plus 4 represent the length of the bases, a base of 2 and a base of 4, the 2 lines that are parallel to one another. I know that's a lot of information. Chunk it out, simplify each part. So the area of the trapezoid is 15, the area of the rectangle is 24, and the area of both trapezoids together is 12. And then our total area of the composite figure is 51 square units. Okay, so that's what we're going to do next, finding the area. So here we have a basketball court. Our court, if you look at that composite figure, you can break it into a rectangle and a semicircle. So the area of the rectangle is 19 by 12. The area of the semicircle, though, remember our semicircle is half the area of a circle. The area of a circle is pi r squared, so we need to look at that radius. So here's the thing, you need to look at that end. The side of our rectangle is 12. That's the same as the diameter of the circle. Half of that is our radius of 6. So 19 times 12 is 228. You're going to do that in a calculator. You're going to write that part down. Then we're going to do 1/2 times 3.14. I can mentally do 6 times 6, so I just wrote that part down. Put those numbers into a calculator. So the area of the semicircle is 56 and 52/100. Add those two numbers together. Our total area for the composite figure is 284 and 52/100 feet squared. Okay, now we have this shape, and it has some dashed lines to kind of help you figure out some pieces. We have a triangle, a rectangle, and a parallelogram. So let's find the area of each piece. So I did the area of the rectangle first because that's the simplest for us to kind of look at. The 8 times the 4.5. The area of the triangle is 1/2 base times height. So the base and height of a triangle need to be perpendicular to one another. So thankfully we have that right angle in the corner there. So 11.2 and 4.5 are the base and the height of the triangle. So 1/2 times 11 and 2/10 times 4/10. And a parallelogram, kind of similar to a rectangle, is base times height. And base and height have to be perpendicular to one another. So that's why you see the straight up and down length rather than that slanted length. So we're going to multiply 6 and 7/10 times 8. All right, take that one part at a time. 8 times 4.5 is 36. Then go on to the next one. And we're using the calculator, right? So 0.5 times 11.2 times 4.5. So the area of our triangle is 25 and 2/10. And then do the last part, the area of the parallelogram. So now in your calculator, do 6 and 7/10 times 8. And we get 53 and 6/10. Add those all up. Our total area is 114 and 8/10 feet squared. Okay, chunk it out, do each piece, and then you're using the calculator to really help you do the mathematics, the multiplication pieces, but you need each step because there's a lot of things happening here, and we could go back and check your work if you make a mistake. So you have two on your own composite figures. So you have the rectangle with a triangle, and then really think about what's happening there in number 4. So you have a square in the middle, and then you have 4 half circles. So think about what you could do there. All right, go ahead and pause the video, work out the answers. You're using your calculator to help you with the multiplication pieces, and then come back, start the video again to check your answers. All right, here's the area of our composite figure that is made up of the rectangle and the triangle. So our rectangle has an area of 9, that should say times. 9 times 7, which is 63. Then the area of the triangle is 1/2 times 6 times 9. And so this is an area of 27. And our total area is 90 meters squared. Number 4, so we have an area of a square, and then you have 4 semicircles, but you could put those 2 on top and bottom together to make a full circle, and then you have the sides, the left and right, put them together to make a full circle, and so you really have 2 circles. So our area of our square is 2 times 2, and then for the area of a circle, I'm using pi r squared, so remember we need radius. So if the diameter is 2 feet, our radius is 1 foot. So, and we have 2 of those. So 2 times 2 is 4. And then now let's work with our circle part. So 2 times 3.14 times 1 squared. Well, 1 squared is 1. 1 times anything is just itself. So you really don't even need the 1 squared because that's just telling you that it's multiplying by 1. It's the identity property. We're going to multiply 2 times 3.14 to get 6 and 28/100, and then add our 2 areas, the area of the square plus the area of our 4 semicircles, and our total area is 10 and 28/100 meters squared. All right, that concludes our little video on area of composite figures. Please make sure that you are working on your essential assignment. This video helps prepare you to do slide number 13. And please ask your math teacher if you have any questions.